Imagine never
being able to dream of landing on Mars or
So we have to ask, why don't we see signs of other life out there?
traveling to Saturn.
There are an extraordinary number of planets in the universe. According to most estimates, planets should be more abundant in space than stars, which is saying something seeing as it's thought that there are upwards of a septillion stars in just the observable universe, just the parts we can see. As we stand then, we haven't yet managed to study even close to 1% of all the planets theorized to exist, simply because we're too far away from most of them. But we have extensively studied those in our own solar system and some more beyond, and although some planets might have possibly harbored life at some other time in their past, we can't say for certain that any do now. Many scientists do of course suspect that there is life on other planets.
Not because it's impossible to get there, but
and probably on one or more of the 2 to 10 billion Earth-like worlds calculated to exist in our galaxy alone. But others argue that the circumstances which led to life on Earth are so spectacularly unlikely that it really could be unique.
Because they didn't exist.
Whatever your view on it, Earth is the only planet we know of that supports life. But why exactly is that? The oldest fossils we found date back to around 3.5 billion years ago.
Because Earth.
We don't have a definitive answer as to how life originally came to be here, but we do have a few theories. One idea, known as panspermia, suggests that life didn't actually start on Earth at all, but arrived here on an asteroid from another planet. Would have had to have experienced an early universe version of something like a lightning strike, that it was in some way electrified.
Earth was the
More recently, in the late 20th and early 21st centuries, some have called for the traditional soup theory to be discarded altogether, arguing instead that life most likely started deep in the sea, near hydrothermal vents, that it was the vents which provided the energy needed to form.
Only planet in our solar system.
Most models now have it that life did emerge out of the oceans and onto land, but there is still debate over how it occurred in our waters in the first place.
It's safe to say that.
The other 8 planets in our solar system,
among these are Earth's magnetic field, its atmosphere, the water cycle, and its size. Even the conditions outside of Earth itself seem to aid our existence.
Aren't just pretty to look at, or something that we strive to travel to one day.
Jupiter, for example, acts as something like a bodyguard to Earth. It's positioned at just the right location in the solar system so that its massive gravitational pull,
even though they're billions of kilometers away,
attracts most of the wayward asteroids that might have otherwise struck our planet. Our own moon, too, is a key player in our planet's habitability, with its gravity helping to stabilize Earth's rotation, which helps to keep the climate steady and the conditions reliable. Water is considered the most vital ingredient for life, and it's almost always the first thing we search for when considering other worlds. But there are some aspects of Earth that are so important that scientists specifically look for evidence of them when investigating life on other planets. Today, Mars has water ice. It's thought it could have liquid water below the surface,
an essential role in life here.
And it's likely that the red planet had lots of water in the past. But the only other objects in the solar system we can say with any confidence have water are various moons, like Jupiter's Europa and Saturn's Enceladus. For this reason, these moons are among the top contenders for harboring alien life. So why is water so essential? Well, it's important for a few reasons.
So, what would happen if they never existed?
The easiest way to do this is to see if the planet you're studying is in the habitable zone around its host star. Earth happens to be positioned inside this range of distances out from our sun, which allows it to sustain water.
For example, take the placement of every single planet. They all have their own little space in the galaxy, and that's not by accident.
If our sun were a different type of star, however, that range would change and Earth would be a totally different, most likely totally inhospitable place. Just being in the habitable zone isn't enough, though. By some accounts, both Venus and Mars are in the confines of the habitable zone at certain points in their orbits, but only one planet out of 3 actually has life.
For example, if Mercury and Venus cease to exist, Earth might drift closer to the sun.
We also have to take into consideration a planet's immediate atmosphere to see what types of gases it's made out of.
Each planet in the solar system played a vital role in the development of Earth billions of years ago.
The average temperature skyrockets to about 462 degrees Celsius, at which point water can only exist as a gas. By comparison, Earth happens to be the right distance from the Sun, and it has a favorable atmospheric composition to sustain liquid water. It's capable of hosting life, while Venus really isn't.
And they continue playing a vital role in keeping Earth safe today.
Water basically acts as a lubricant to facilitate all the complex molecular chemistry that occurs on Earth.
And if Jupiter or Saturn disappeared,
but it also moves, redistributes, and facilitates other chemical processes all over the planet.
Instead of getting closer to the Sun,
at the highest level, it creates and destroys land. It ensures that our planet's surface is always under development.
The Earth might drift further away from it.
Venus, for example, is just on the inner edge of the habitable zone and has some of the right conditions to maintain liquid water on its surface, but not all. Not by a long shot.
This would cause a number of issues for us Earthlings.
At the highest level, it creates and destroys land. It ensures that our planet's surface is always under development.
Right now, we're lucky enough to live in what scientists call the Goldilocks zone. They call it that because Earth sits in the range of orbits around the Sun that are just right to sustain life. If Earth were to move closer to the Sun, it would get a little bit hot. We might burn to a crisp.
But it also moves, redistributes, and facilitates other chemical processes